Hi everybody, my name is Lee Souter. I am a concept designer based around New York City, and today I want to show you how I use Grasshopper. I've been using Grasshopper for about 5 years, and I'm trying to integrate it into a concept design workflow. Uh, Now's a good time to show a tutorial because Grasshopper is getting faster. It's finally becoming multi-threaded. That was the biggest bottleneck, is if I wanted to add some interesting parametric detail, I would have to wait a long time for the node structure to process. So Grasshopper is slowly becoming multi-threaded. Not all the nodes are multi-threaded, but it's getting quicker. I use Grasshopper to create curves, surfaces that can be used with programs like Fusion or Moe 3D. And then the best case is to actually generate a mesh with nice topology, but that's not always the case if you're Boolean um, different surfaces. It's always hard to mesh those surfaces, but you could build the mesh from scratch, and I'm going to go over that today. And I'm not going to go, I can't go over all the nodes up here. There are plenty of tutorials to go over every single node and what they do. But today is just a case study, and I'm just going to create a hexagon grid like I made here. This is all meshed. It has nice quads, and I'm going to show you how to do that. So first of all, you need Rhino 6. Rhino 6 comes with Grasshopper right here. It's excuse me, it's already integrated into Rhino. So you click that, and then Grasshopper will load, and you have a window on top of Grasshopper. You have the Grasshopper window on top of Rhino, and these two are linked together. So anything you create in Grasshopper will show up in red in Rhino. Red if it's not clicked, and then green, whatever you select will turn green in Rhino. So let's get started. In the Grasshopper window, at the top, go to Vector, and then you're going to go to Grid, and go to Hexagonal Grid. Click that, and then it will be attached to your mouse, and you can place it anywhere in your workspace. You can also double click and type hexagonal grid. So there's two ways here. You can either find it up here with all the little icons, or you can double click and find your node through the searching directory. Of course, this way, double clicking and searching is much more efficient. And here we go. Here's a node, a Grasshopper node, and let's say you open up somebody else's definition and you want to find out where this node comes from. You can Control Alt, and it will tell you at the top with these arrows where this node can be found. Now, this is just like any other node structure where there's inputs and outputs, but Grasshopper is really powerful because it works with this data, these lists of data, which can be rearranged in a way that gives you different patterns, and it's really easy to work with and understand. So if you hover over this node, you can see what each one of these inputs is asking for. We have a plane. That little black hexagon is telling you what kind of data it wants to accept. So this is looking for planar data. The size is looking for a number, a decimal number, and then this 7 represents a whole number. It's only asking for whole numbers. You can't have half of a hexagon, so it's only going to accept whole numbers. So if I just double click and I want a number, any number, I can just type in here 2.3, and it will give me this slider. And the slider contains a domain of numbers. Since I typed 2.3, it's guessing that I want a range of 0 to 10, but we can change that later. So you just plug this in to size, and now you can see in Rhino that the size of the hexagon is changing, and you can slide it, and eventually the slider can be programmed with other kinds of data where it will grow and shrink according to different parameters. And now for the hexagon cells, you can change the amount. If I double click, I'm going to get another, I'm going to put another number in here, maybe 3. I need a whole number, so I'm just going to do 3, and then another 3. Well, let me show you. If I type 3.2, it's not going to accept, it's only going to accept whole numbers. So once it gets to 4, it'll add another cell. 4 or 5 or 6, it'll add another cell. And the plane, you don't have to change that, but I'm going to change it so I can hide it. This represents the plane that it's lying on, and I want to get rid of it because it's in the way. So double click, and I'm just going to type, I think it's XY plane. Wait, let's see, XY. Okay. So now I'm just reintegrating that data, and now I can hide it. And now the plane is gone, and I can see just the hexagon structure. Now the outputs are cells, which are the hexagon curves as a whole unit, and then P, which are the points, which are actually the center points of each hexagon. And you can't see the points, and you can't see each individual cell, but you can see the data that is coming out of that output by typing in panel. And let's take a look at what is coming out of this output. You can see that the data is organized in rows and columns in this nice format. So you have 5 columns and 3 rows. So 3 rows and then 5 columns in each of that row group. So it's nice and organized. But you might want to change this data later according to whatever you're creating. And one way to do that, one way that I use all the time, is you can flatten the data, which would just give you an unorganized amount of hexagons, or you can graft it, which will put each hexagon into its own container, its own little slot. But I'm going to take that off for now. So yeah, each one of these icons, each one of these pieces of text, you can right click, and there are options. Let's see what's coming out of the P, the points. Obviously, it's the points of each hexagon, the center point of each hexagon. And then again, I can flatten it or graft it. And this flattening and grafting will be very important later on. Okay. Moving on, now I want to have some fun and parametrically scale these hexagons according to a point in Rhino. First of all, I'm going to move this panel down here. Maybe I'll just delete it. And now I'm going to look at the scale node, the sphere and the little sphere, and take a look at this. It's looking for geometry, it's looking for center, it's looking for points, the center of the scale, and then the factor, how much it's going to scale by. And the factor already has a parameter in there of 0.5. So cells are the geometry. I'm just going to plug that in there. And you can see we have the hexagons appear scaled 0.5 according to the center point of the world right here in green. But we don't want that. We want to scale each individual hexagon. So we're going to have to find each individual center point of the hexagon, and thankfully it's already created here coming out of the hexagon grid node. And you can see there's 15 values coming out. There's 15 values of cells, so they match. So Grasshopper is going to have no problem understanding what I want to do. There's equal amount of information flowing into this node. And now we have a scaled hexagon, and we can change that if we just double click and add a number, I don't know, 3.4, and we can scale that hexagon according to this number. Now you can see I over-guessed the amount of scale I want to use, so I could either retype the number. I see that 1, I want it to end at 1. I want my slider to end at 1. I could either double click and retype the number, or I can actually edit this slider itself by double clicking on the slider, and you have a bunch of parameters here. I want the maximum scale to be 1, and the min scale maybe to be 2, 0.2. Oops, what happened here? 1, there you go. 1 and 0, okay, that's good enough. And let's do 2 decimal points, so it's sensitive. All right, now I can scale those hexagons according to, I have a domain, a safe domain to scale those hexagons. As you can see, if I go too far, the node turns red and tells me that's an error. You can figure out what that error is by this little bubble. It's telling me cannot scale with a factor of 0. Obviously, that's the problem. So once I go up a little bit, it'll come back. Now, I want to scale this according to the distance of a point. It'll make this pattern more interesting, and we'll have a nice gradient. And then we can update that point, and it'll change according to wherever I put that point. So first we need a point. So I'm going to go to Rhino and make a point, and just click that point right there. I can also make a point from scratch in Grasshopper, but for now, let's just use a point that's in Rhino so we can move it manually. Now I need to bring this point into Grasshopper, so I have to make a point container. So I just type point, and since the point is already selected, I right click on the point container and say set one point, and your point turns to a nice little red X, and it turns green if I select it. So now that point is in Grasshopper, and I want the hexagons to scale according to their center point and to the point that wherever it's placed in Rhino. So to do that, I need a distance node. Distance A is the point. Point A is the point that I placed in Rhino. It could be A or B, it doesn't matter. And then B is going to be all the points that the center points of the hexagons are going to go into here. And you can see it's 15 numbers. It understood that you're going to take these 15 center points and you're going to need 15 points. So it duplicates 15 points and gives you 15 different numbers. And if you look at the panel, you can see you have 15 different numbers, which are the distances. Now if I plugged it into factor, the domain is too large, so I have to shrink that number down, and we're going to shrink it by multiplying a fraction. So I'm going to take the distance and then this slider that we already made and plug it into factor. Now I can scale those hexagons according to my domain. Now if I move this point around, it will scale accordingly. Wherever I move that point, those hexagons will grow and shrink. I can even add more hexagons and it will scale accordingly. I can take some away. And this is the power of Grasshopper. Everything is parametrically organized. Let's pretend that we are happy with our creation and we want to export it. In this case, we want to export it into another CAD software like Moe 3D, Fusion, SolidWorks, or Rhino. First of all, the data that we see here is not in Rhino. It's just a glimpse of what it will look like once we bake it. So we have to go and bake this geometry into Rhino to export it. So I want to export the scaled hexagons and not the grid. So I'm just going to bake this node, but just to make things easier, I'm just going to hide this node. Right click and go to preview, and it will turn that preview off. And now I'm just left with my scaled hexagons. So to bake it, all you do is right click on the node and go to bake. It will give you some options and what layer you want to bake it to. It's going to do the default. And it looks like nothing happened, but that's because the Grasshopper layer is visible on top of the Rhino layer. So if I select all these hexagons and just type export in Rhino, hit enter, and now I can export the IGES file. It'll give you some options. Pretty self-explanatory. Cool, now I have some curves that can be used in other software. I made a pattern in Grasshopper, and now I can use that CAD pattern in other software packages. So I'm just going to undo what we did in Rhino to get rid of the curves. And now let's say I want to import these hexagons into Maya or ZBrush or any other software package that uses polygons. I need to give these hexagons a little thickness. So I'm going to use the scale again. And I'm going to plug in the geometry that we already scaled and scale it again. I'm going to use the same center points I did from the hexagon grid, and I'm going to scale it by a factor of 0.75. But you can change it, to whatever scale you want your hexagon to be. I'm just going to do 75, 74. Now that I have these two curves, I want to loft them together to make a surface, and then I'm going to take that surface and mesh it. So I'm going to type loft, and the loft is looking for curve data as a list of curves, and then O is just for options. I can right click and there's some options down there. But I want these curves. I want the small curves to be lofted to the larger curves. And we get a mess. That's because the data is not organized properly. We have to graph the data so that each hexagon is individual. What I mean by that is if you open up the panel and you look at the data, there's groups of hexagons. So Grasshopper is lofting 0 to 4, 0 to 4, 0 to 4, and you get all these extrusions that we don't want. So we need to graph the data. I'm going to graph this. Well, let's take a look at what's happening. If I graph this data, it will put each hexagon into its own container. Now each hexagon is individual, it's not grouped. So graphed. And then I want to do the same thing here. I want to graph this. The only issue is if I graph this, it's going back into the scale data and double grafting it, so it's making another mess. So I'm gonna ungraph this. I'm gonna put this geometry in its own little container so I can graft it by itself. Sorry, did I go too fast? So I'm gonna double click and type geometry, little geometry container, and I'm gonna put these curves into this little geometry container. Now I can graft it by itself without interrupting this data. So I'm going to graft, and I have to get rid of this information. So I'm just going to disconnect all. So you can right click to C and go to disconnect all. Sorry, let me show you that again. Right click and go to disconnect scale, or sometimes it'll say all if there's multiple inputs. So now we have our data grafted into individual units. The loft should work. So let's bring these curves in and shift. You have to shift to add inputs on top of another. And now the loft is complete, and you have nice individual thicknesses for your hexagons. If you're happy with the surface, then you can export the surface and bring it into any other CAD program, but I want to bring this into Maya or ZBrush, so I need to mesh it. So I'm going to go to Mesh Surface, and it's this guy right here. And I'm going to take this loft and mesh it. It's asking for a surface, and I'm going to bring it in here. And it doesn't work because it tells you here, data conversion failed from BREP to mesh, because if you look at this loft, it's a BREP. A BREP in Grasshopper is a solid surface or a collection of surfaces. So this mesher can't mesh a solid surface or a collection of surfaces. It needs individual surfaces to mesh. So we have to explode this loft into little sections. So we have to go up to deconstruct BREP, which is up here in surface analysis, deconstruct BREP. And this will take your BREP and blow it up into different parts: faces, edges, vertices. We want faces. Plug faces into the surface. If you look, the icons match. You have a hexagon that has a surface on it, a hexagon that has a surface on it, and they match. And if you zoom in, you can see that you have a mesh underneath. It's a little hard to see, so let's hide this loft preview. Right click on loft and hit preview, and it'll disappear. And let's also get rid of this explosion preview. Now you have a preview of what the mesh will look like once you bake it. I think it's a little dense, so I'm going to change the U and V grid structure. Let's do 3 and maybe 2, and plug those in, and maybe 3. If I smooth that in Maya, maybe it'll be nice and round, but you can add as much as you want. So now I have the hexagons meshed, and if I notice that I don't like the thickness, I can always update the thickness on the fly. I can change where this point is scaling everything. And once I'm happy with my pattern, I can export it. To do that, I have to bake it first. So I'm going to go all the way down to Meshed Surface, right click, and go to Bake. It gives me those options again, OK. And now I can select those meshes and type Export. And in this case, I'm going to use OBJ. Oops. And there we go. We exported the hexagons as CAD data or polygonal data. As a concept designer, now I have a quick way of applying mesh detail or CAD data detail to a surface. Now that I built this definition, I can use it at any time. I can save it. Let's save it. And I can manipulate this little structure, and I can use it for other times. And now it's all set up. This was the hard part, with setting it up, but now I have a primitive that I can manipulate if I want to add some type of hexagon detail. Now, a more practical use of this pattern would be to apply it to an actual surface, and I'm going to show you how to do that. For an example, this is a skull I made. I added this hexagon window on the side, and this is all done with Grasshopper. But I brought it into Maya and manipulated it a little bit just so it made more. The topology was a little better. I had to clean up the edges, so Grasshopper doesn't always do a perfect job. Most of the time it does. So I need a surface to work with in Grasshopper and Rhino. So to extract a surface, I'm just going to get some curves from this mesh. I'm going to select the edges, and in Maya I have to go to Modify, Convert Polygon Edges to Curve, and I'm just going to make a couple of these to show you an example. So just push G to redo, G. Now I have 3 curves that I can use to make a surface in Rhino. Export. I'm going to do IGES. Now if I go back to Rhino, I'm going to import. You can just type import. I need to find the temp IGES file, and it should have imported it. It's way off in the distance. I'm just going to click on it and shift and move it closer in Rhino. And then I'm going to loft this surface so I can work with it in Grasshopper. Loft. Okay. Now I have to bring the surface into Grasshopper. So I'm going to click on it. I'm going to double click in Grasshopper, type surface, type SRF, and surface will come up. I'm going to put my my surface in Rhino into a container in Grasshopper. Set one surface. That might be off the screen. Right click, set one surface. Now the surface is in Grasshopper, and I want to take these hexagons and apply it and map it to this surface so it follows the curvature. To do that, there's a node called map to surface, and this is asking for curves, source will define the boundary of your curves that you're applying, and then target is the actual surface that it's going to stick to. So let's add this to target, and then I have to go into Rhino and make a plane that surrounds this geometry. I'm just going to use this 4-point surface creator. Let's create 4 points around my geometry. Another surface container, SRF. Oops. SRF surface. Shit. SRF surface. There we go. Click on the plane. Right click. Set one surface. And now this is telling map to surface how you want to map those curves to this surface. Now I put the curves into this map to surface node. The only problem is if I put the outer curves and inner curves into this map to surface, they're going to be all jumbled into one node. So I want to have 2 map to surfaces. So I have the outer curve and inner curve of the hexagon separated, so I can loft them easily. So I'm going to duplicate this map to surface node, and when I duplicate it, it keeps the attachments of these surfaces. So the first one I want to connect is the outer curves that are in this container, and then these curves here. And now my hexagons are mapped to the surface. I have the outer and inner curves, and I'm just going to do the same thing again and loft the curves like I did before. They should work now since it's grafted. Let's see. It's hard to see. I'm going to hide these two inputs. If you can drag a window around them, and then right click outside the box and hit preview off. And there we go. The surface mapped. The hexagon pattern is mapped to a specific surface. In closing, this just scratches the surface, and this is my personal example of using Grasshopper. This is also my first video tutorial in a series I imagine myself creating. So if you find this useful, please let me know. And if I get enough positive feedback, I will try to make more. And this is my concept design workflow. I just use it to create primitive starting geometry. I don't use Grasshopper for the whole entire model or project. This is just how I create quick detail with nice topology. So I save the definitions for later use. And some other things you can do is you can go to places like Pinterest, and you can find and scavenge for other people's definitions that they post. YouTube has plenty of tutorials on Grasshopper, but again, I'll try to make some more in the future. So please follow the links below, and thank you. Have a good day. Bye.